So now we could just go ahead and press the green button, and it will take us to our next step. And the next step is to place the IDF bags, all 6, and clamp bar B on the instrument. Same exact positioning that we had before with the SDF bags, where we place the top of the bag on the nozzle, so the nozzle is inside the bag. We make sure again it's even with the 2 lines, and as Chris did initially here, we make sure that the bottom of the IDF bag is inside the top of the SDF bag. We also make sure that the bottom of the SDF filter, the IDF filter is just above clamp bar C. And when we do that, the top of the IDF filter will be just below clamp bar B. So again, we've got the bag equally distributed between the 2 lines. Bottom of the filter just above clamp bar C. Top of the filter just below clamp bar B. And again, each IDF bag inside the SDF bag below it.
How about the skirt, Brian?
We mentioned briefly earlier, there is a covering, a polypropylene covering on the filter itself that we call the skirt. And when the bag filters, none of the filtrate will come outward. It will all go downward into the SDF bag, and that's the purpose for that skirt or that covering of polypropylene. So we have one more bag to do, and we will then place clamp bar B on the instrument. And just as an introduction to clamp bar B, we have at each IDF bag we have some pressure points, and you'll notice that when you have your instrument, you'll notice that there are 3 pressure points for each bag. This gives us the ideal amount of agitation to get during the digestion process. All right, so clamp bar B is in place. We've already done all the SDF production, so now we can press the button and clamp bar B will go ahead and close also. So now that we have clamp bar B closed, we're ready to place the samples in the bags. And just as we place the diatomaceous earth in the SDF bags, we will do the same with the samples. Again, trying to make sure that all the sample goes below the nozzle, the white nozzle that is in the bag. Of course, as we've mentioned before, we are doing duplicates, so bags 1 and 2 have the same sample. Bags 3 and 4 also have the same sample, and bags 5 and 6 will have the same sample. If you're using our Excel spreadsheet for your data, bags 1, 3, and 5 will go to protein at the end of the process, where bags 2, 4, and 6 will be ashed.
Brian, how do you handle liquid samples?
Actually, liquid samples are quite simple. We have found a lot of success using a disposable pipette, a 3 ml pipette. We will place the empty pipette on the balance and tare the weight. We then fill the pipette with sample and very simply empty the sample into the bag. We know that there will be some sample remaining in the pipette, so we very simply place that back on the balance and determine how much sample is still in the pipette and subtract that from our original sample weight. Very, very simple. What becomes a little bit more complicated is the moist samples, not completely liquid,
Like
but
yogurts and things like
certainly
that.
not dry, yes. What we found with that is if you take your spatula, again, same as we did with the disposable pipette, place your empty spatula on the balance, tare the weight, and then fill your spatula with your sample, and of course record that weight, and then come over to the bag and try as best you can to dump that sample, in this case yogurt, into the bag. You may have to actually scrape it into the bag using another, maybe another spatula, something like that. And then, again, take your spatula back over to the balance, because it's very difficult to get all of that sample off your spatula. Take your spatula back to the balance and determine how much sample is still on your spatula and subtract that from the original sample weight.
So you'd have to have a fairly wide spatula in that case in order to make sure you're holding it a half a gram or
Depending on how moist your sample was. Okay. Yes.
Now, I do know that I had one customer actually in Australia that was doing ice cream, surprisingly, and they were telling me that they were now freeze drying the ice cream in order to do it. So there's different options. Again, maybe with your conventional method, you have some particular ways of handling certain samples to go into your beakers, and you can always try those as well.
Ice cream certainly would be one of those wet samples, those liquid samples, if you allowed it to melt.
That would be another option.
Sure.
Never thought of that.
Okay, so now we have the sample, each sample in the IDF bag, so we can go ahead and press the check mark. And the next step is to place all the remaining clamp bars onto the instrument. Chris has just placed clamp bar A, excuse me. Now clamp bar C has some interesting attachments. Each of these attachments has a barb on it. And what we want to try to do, we're going to place bar C, which again, this is bar C. We're going to place bar C just below bar B. And once we have the bar on, we're going to go ahead and place the check mark. Press the check mark, excuse me. Now, this particular screen tells us that the front of the SDF bags needs to be hooked to clamp bar C. So we want to make sure, what we'll do is just raise the SDF bag, in this case bag 1, and then just set it down on that barb, and it's actually going to create a physical hole in the front surface of the filter bag. And the reason for this is because we will have enough mass of solution in this bag that the weight tends to pull the bag down a bit. So by placing the barb into the bag, that gives us plenty of support for that weight that will be in the bag. Okay, so now we have that in place. We can go ahead and press the check mark. Now the next step is to make sure that the fluid levels are correct. We have eight different fluids. In this case, this is distilled water. And you may or may not be able to see it, but there is a line on each of our containers, each of our plastic containers at least, that will tell you how much solution of that particular container needs to be in there. So we make sure that we have enough solution in each container, and we have done that ahead of time, so each one is in position. But before we go on, let's talk about both sides. A couple of things that are very important. You will notice that, and again, you may not be able to see that real well, but the distilled water has a blue label and also a blue neck liner. And the instrument has a blue male connector and also a sticker that says distilled water. If you make sure that all of the colors coordinate, blue on blue, with the buffer it's green and green, with the 78% ethanol it's red and red, and then with the 95% ethanol, which is a very large container, it's white and white. Very important that we make sure the colors are connecting to one another. Over on this side, we have our acid, our HCl, and this is the one that we do not have a connector, specific connector for like the others. So we have a plastic barb here that you can place into the tubing. The reason we don't have the connector is because the connectors have metal and the HCl does not like metal. So we've found that this works much more easily and much better.
More robust instrument.
Yes. And then the last three solutions, of course, are the enzymes. And again, color coordinated. We have the three from back to front. We have Amylase in blue, Protease in red, AMG in black, and making sure that when the solutions are placed in the instrument, you'll hear a click whenever that is in the perfect position. So making sure all of the solutions are full enough, and then at the same time all the solutions are in the color-coded positions. Last thing, when the instrument starts for the first time of the day, you will need about 10 ml of enzyme for the first run. It does a line charge, and we'll talk about that as we go, but it'll do a line charge, and then each of the bags receives 1 ml of solution, of enzyme solution. So you'll need at least 10 ml in each of these containers. All the other containers do have that line that we talked about to tell you how full the container should be.
But you can have the containers full all the way.
Certainly.
It just means less time of you refilling it. But you have to have it at least to the line in order to cover a run.
Certainly. Okay, so we can press the button as we have all of our fluid levels correct. Our nitrogen supply is on. If it were not on, we would have received a fault a long time ago. But in this case, all we have to do is look at our two gauges over here, and we can see that the supply line is good. And we can also see with this gauge, and actually this gauge duplicates this one, we can see that there's plenty of nitrogen supply for each of the bags as we go.
However, one thing that is important is for you to also be aware of your source, because we could have pressure to here with the source, but if we have just a small amount of nitrogen available in the tank, at some point that will run out, and that will cause us a nitrogen fault during the process. So we want to make sure that we have an adequate supply of nitrogen at our source.
Yes.
So we can push this, and now it's saying filter minutes okay. What is that all about?
Well, during this process, of course, we have a filtering that's going to occur in the IDF phase, and we have a filtering that's going to occur in the SDF phase. We want to make sure that there is enough time for the filtering to occur, and this gives us an opportunity to actually change those set filtering times. Factory settings are in the little white squares, which you again may or may not be able to see real well. But if you wanted to change one, all you have to do is press that square, and you'll have the opportunity to make that adjustment on a pressure button over here. So we'll keep it the same. And we have a smaller amount of time for the IDF filtering and a little bit longer time for the SDF, simply because there is a lot more solution to be filtered through the SDF bags than through the IDF.
And one thing to emphasize here, maybe Brian, I'm interrupting Brian, but maybe he was going to go into this, but just in case, the factory settings are based on our experience with samples from all over the world, quite frankly. And so we know what the basic filtering times and rinses are for the majority of samples. However, during the filtration, there is an opportunity for you to both add filtration or deduct, or bypass, I should say, filtration. So as long as you are there when the filtering is happening, you'll actually have an opportunity to add or subtract depending on what the needs are.
Yes, and of course there are exceptions where you may have a sample that filters much more quickly, and you may have a sample that takes a bit longer to filter. So that would be the opportunity and the filtering time. If you don't make the changes now, that would be that point during the filtration time where you can add time or end the filtration that Chris talked about.
And I would even add that one of the things that's nice about this is if I knew I was doing a run that would take filtration to perhaps when I'm on lunch, in this section I might go ahead and increase the time just to make sure that I don't have any problems while I'm away from the instrument. That way when I come back, I could say, oh, it's already filtered, I could simply hit the bypass. But that's just a good way to manage your time up front based on your experiences.
So we'll go with these filter times. We know that these filter times are good with these particular samples. The last few slides, or the last few pictures here that we have, this next one is to check the pH manually. And of course there is a checking of the pH after the protease phase, but before the AMG phase. And we will go ahead and say yes to that. We would suggest that you always check it. If you constantly run the same sample over and over again, and your acid is consistent, and of course your buffer is consistent, which it should be, then we would suggest that perhaps you can bypass that in that instance.
And even the AOAC method does give you that allowance. Based on experience, you can change the concentration level of the acid in order to bring your pH in range. So again, AOAC does give that as an option for you based on experience and based on the concentration of acid. But I believe the method starts us with a 0.561 normal hydrochloric acid, and that's what we start with. Again, that can be adjusted based on your experience according to the AOAC method.
And we would adjust the pH between 4.0 and 4.7.
Now, I should also mention, it's important to realize that you are checking the pH, but the system, as the method requires, automatically adds the hydrochloric acid, mixes it before you do that pH check.
Absolutely. All right, so now we're finally in the place we wanted to be. This is our start button. So in pressing start, go ahead and do that, Chris, if you would. The instrument is going to do a line charge, and what it is doing is it's taking all of the solutions from their positions. It will start over here to the left, to do the 4 solutions on the left, and then it will come over to the right and do those 4 solutions. It's taking all of those solutions to a central location in the back of the unit, so that when it begins to deliver the solutions into the bags, all of the bags will receive the same amount of solution. A very important step. Now, if I do one run and then do another run immediately afterward, the line charge is not necessary because all the lines will be fully charged and will not need to have that process done at that time.
And that's unless you turn the instrument off or you have the instrument sitting for more than 12 hours with the power on.
So we're doing, the instrument is automatically doing the line charge. Right now it's into the next to the last solution. And then what will happen, we'll have a little bit of a quiet time here for a few seconds as the instrument begins to warm up. And actually what is warming, and we probably should have shown you in this initially, is behind each of the IDF bags there is a metal square. And that metal square does 2 things. A, it's the paddle that gives us the agitation and the motion of the solution during the digestion. And B, it also is a heater, and it heats the solutions to the appropriate heat, the appropriate temperature. We want, of course, in the amylase phase, which is our first step, we want to have that temperature get up to 95 to 100 for at least 15 minutes. So we preheat the paddles to 50 degrees prior to the delivery of any of the solutions.
And then from there it'll go up to at least 90 degrees, and then the system will say, okay, for 20 minutes run the amylase, and that guarantees us the at least 15 minutes at 95 to 100 during the process. The reason why we do it that way is because different laboratories have different environments. We've been into laboratories that quite frankly are quite warm, yet we've also been in laboratories that are quite cool. So we have to account for the varying heating times in that, and that's why we made the software to do that. One other thing I should point out that the system did in this process is after it did the line charge, and while it's heating up, it also did what's called a pump tube integrity test. And what it does is it pressurizes all the tubes, and it makes them hold pressure for a certain period of time to confirm that there's no leaks or bulges in the tubing that might affect the operation. So that is done with every run. It checks to make sure that there's no leaks into the system. So now, Brian, it's doing the paddle heating. It's going to take a while for it to get up to the 50 degrees. We're going to see the buffer and amylase go in, and then it'll start heating up again, continue to heat up until it's 90 degrees. So we'll pause right now, and in a second we'll be back, and we'll show you when it's at the 50 degrees.